Hello. So today I will be solving median of two sorted arrays, which is quite extremely difficult for me. It took like almost like 7 hours to understand all the concepts and alternative solutions and other stuff, and its implementation roughly. Um, so usually I don't do this. I usually think out of my head and try to figure out the solution, but it was impossible, so I referred to the solution, and that solution is quite extremely difficult to understand, so I took some time to understand it, and now I want to do this after after going through all the solutions that are in the web. um, so there are two or three ways, including the dumb one. So let's start from the dumb one. Um, I haven't described the problem yet, so let me explain. So given two sorted arrays, um, nums one and nums2, sorted is very important in this problem. Um, and you want to basically think of the array that is that consists of all the elements in the array, first array and second array, but sorted, and you want to return the median of that array. And there is, so simply concatenating these two arrays sorted on top of it will require m plus n, all of m plus n log n plus n. Computation complexity. M represents the number of items in the first array, and representing the number of elements in the second array. And the problem asks you to solve this problem in such way that it only takes runtime complexity of O of log m plus n. And this is what makes this problem extremely hard. Um, so yeah, this is why I took some time to understand, like I said earlier. So when you see log of n, that means it involves binary search, or whatever techniques that reduces search space, or something that involves with runtime complexity by half each steps. So this is actually, this is what makes the problem harder, but this statement is actually giving us a hint. So there are two approaches as far as I investigated. One is to consider partitions in each input arrays, and that partition represents that all the elements in the input array before the partition should go to, let's say, virtual array. Virtual array represents virtual represents the array consists of all the elements from the first second array, but sorted. But we are going to now split this virtual array into two. The younger part, the no, I mean not younger. How do I put it? The smaller part. Okay, the smaller part and the larger part. Okay, and this partition is going to represent that all the elements before the partition in the array should go to the uh, smaller virtual array, and and on the other hand, all the elements after the partition should go to the uh, larger part of the virtual array, okay? And the idea is that, okay, there should be partition somewhere in the array, okay? I mean, I'm saying partition, but it's actually partitions, because we're going to find two partitions in each arrays, input arrays, okay? And it should be somewhere, and we're going to use binary search to find the proper position. So let me base on the input array, first input array. So first input array, and there's second input array, but we're going to consider about first input array, and the partition should be somewhere. And partition could even be after the last element, meaning we're going to extract all the element in the first input array to the virtual smaller array, okay? So it should be somewhere. So we're going to start from the middle. So we kind of have like a pointers. The one pointer pointing at the beginning of the array, and the other pointing at one after the last element. So this is outside of the scope of the array, because we want to kind of like we want to have the possibility to have the partition outside of the scope in case we want to put everything in the array, in the virtual or smaller array, okay? And then we get the middle, and middle is like a candidate partition, like possible partition that we just thinking right now. Think of usual binary search. We're going to consider middle, and if it's bigger or lesser than the target, and if it's larger, then we get then we want to drop all the half or the one another. So that is simply applied to this problem too. So we get the middle in the part as a candidate partition, and if and also important thing to know is that by the definition, partition represents the point where points that determine whether or not the item should go to the smaller one or larger one. That means partition is located around the median index of the virtual array, okay? So we can later utilize this information to extract what we want, okay? And yeah, so by this definition, determining one partition in one array can determine the other partition in the other array. And so we have two arrays, and then we compare the maximum item of the virtual smaller array, and that maximum value in the smaller part of the virtual array should be smaller than minimum number of the larger part of virtual array, right? If it doesn't, then it's either value right before the partition in the first array is larger than the value right after the partition in the second array. So in that case, we want to because it's larger, then we want to search from the left hand, right? So because the right hand is even larger than that, so we want to decrease the number by dropping the bigger ones. Okay, so the partition, look, okay, so we have the middle, and it's the value right before the partition is larger than the other right hand minimum right hand, then we want to continue by dropping the right hand. And the other pattern is that um, the value right before the partition in the second array, this array, is larger than the value right after the partition in this first array. So what we want to do is to decrease the number of items that we get from the second item, meaning we want to uh, continue searching, but dropping the left part, because if we're going to adopt partition from the left part, that means we get more item from the second array, which is not what we want. We want to increase the number of items that we select from the first array, decreasing the number of items that we select from the second array. So that is the overall very high level explanation of this first approach. The second approach is how was it? I completely forgot. Okay, window. Um, Let me remember real quick. I have cheat note. Yeah. But I need to be able to speak up without seeing anything. So I'm going to always revise. All right. So it's kind of similar. Second one is kind of similar. So we have two input arrays, and we're going to get the middle, and we're going to get the middles of two arrays, and and what was it? And okay. We're going to consider middles of two arrays, and we call left hand of input array, first input array left, let's say A left, middle being A mid, and the latter being A right. A left, A mid, A right, and B left, B mid, B right. And we are going to basically extract item as much as the target value. The target value is the index, not a index, because index starts from 0. I want to start from 1 in this case. So let's say like placement of the median in the virtual sorted array. Okay, So let's say we want to get fifth. Let's say the median lives at the uh, fifth place. Then from these two arrays, we are going to compare. No, hold on, wait. So we have this pool of items, and let's say it's 5 and 5. No, because median, I'm saying median lives at 5, then it should be 11. So 5 and 6. So 5 items, 6 items in the first array and second array. And if 5 plus 6 divided by 2, ignoring the decimal places, it's 5, right? 5 is equivalent to the target that we're looking at. It's 5, right? So if that is the case, this is a pinpoint. So let's say the length of half of the joint array is actually larger than the target that we're looking at. That means we can remove the right hand, but we cannot remove, right hand, but we're not sure what exact items actually corresponds to those values, and we want a safe way to remove. And for that, we're going to compare A mid and B mid, and let's say A mid was smaller than or equal to B mid. That means A left is smaller than or equal to B right. And likewise, no, I think that's it. So so the explanation that cheat chart that I have right now is saying is like we can remove B right safely. Because A left, B left put together, or put together it seems like A left, B left put together surpasses K, so we can safely prune B right. Okay. No, not actually. A left, B left put together surpasses the half, the middle, right middle of the total length of the half. And we know for sure K resides on the left half. And why are we sure that A left, B left to put together is greater than the middle? Because that's how we define it. Oh yeah, because that's how we define it. Okay, and if total length of A input array A and B divided by 2, ignoring decimal places, is smaller than K, that means K's value resides on the right side, so we can prune the left part. But when pruning left part, we cannot remove both left part from the both arrays because yeah, because one left hand might be actually larger than the right hand from the other array, so we cannot remove the larger one for sure, but we can for sure remove the smaller one, smaller part of smaller left hand arrays. Yeah, and prune it, and if we prune the left hand, that will change the target because we were looking at the 5th place, but the element before the 5th place now is getting removed, so as much as it removed, as much items being removed, how do I put it, like we need to subtract as much items being removed. Yeah, that's what I wanted to say. And keep doing the same repetition. Find the middle of the two arrays and compare the number of items of the input arrays put together with the placement that we want to find. Prune it if necessary, and 終了条件. I don't know how to say 終了条件 in English. Termination condition. Okay. Termination condition is that so as we get into the kth placement, Mm. Um, okay. Let's, because this is implementation specification, so it's kind of difficult without having a code. So the overall idea is that we keep pruning items from the arrays. Doesn't necessarily mean physically delete it from the data point. We going to implement this by defining window. And okay, narrowing down the windows. Narrowing down the windows, and eventually we are going to um, mm, yeah, that's where I'm confused. Yeah, I was studying this solution and I understand that, but this solution, cause I don't understand the termination condition. So it says the window. This is very quite in detail, but it's checking a star is actually passing a end, which I think I am confused, which I am confused because I am not sure if that actually happens. So let me ask this question with Claude. You can clearly answer this question. Oops. Does this happen? Does this happen? Okay, that's the question. Okay. Question 1. A start is greater than a n. Does this happen? Example scenario, looking for k equals 3/4, smallest element. 2 plus 4, 6. So yeah, third place, fourth smallest. Okay. Through recursive calls eliminating elements from A, we might reach a state when a star is 2, a and 1. Since a start, a and array A is exhausted, the answer. Let me think. So middle A let me see the implementation. How we get the middle? We get the middle a star a end divided by 2. So that means 0 plus 1 divided by 2 is 0. Middle is 0. No. So 2 plus 4 equals 6, and 6 compared to 3, is it 3? What we is that what we compare? All right. Um, 6 compared to, okay, so we want to get 4, right? So 6 compared to 4, obviously 6 is bigger. So that means fourth smallest element resides in the left. So we can put the right, and right half, the bigger right half is in this case B right, and B right is from, because I'm going to evaluate the B right from where and until where is B right. It's from 0 to 3, so 3 divided by 2, ignoring the decimal places, it's 1, so 1 is the middle, and the rest on the right is the right, B right. So 5 and 6 will be removed. So next is 1 2 being the A, 3 4 being B, and 2 plus 2 equals 4. No, 2 plus 2 equals 4 divided by 2 is 2, and 2 compared to 4, no, hold on, oh yeah, 2 compared to 4, obviously 2 is smaller. That means fourth smallest element resides in the on the right, so we can prune the leftmost subset. In this case it's A, it's 1 from A, so remove 1, so now it's 2 and 3 4, and 3 divided by 2, of course ignoring decimal places, is 1 compared to 4. No, I mean when we remove 1 from A, just right before, we need to decrement the target K as well. So now it's 3. Okay, now it's 3, and 1 plus 2 equals 3 divided by 2, ignoring decimal places, is 1, and 1 compared to 3 is larger, so that means it resides on the right hand, so we can remove the smallest left hand, which is in this case 2 from A, array A. So remove 2 and also decrementing the target to down to 2, and what we get is so we had 2 inclusive range, so the range, like, it was like range start A was 1, range end A was 1, and now because we want to delete 2, okay, so we want to delete 2, then we're going to set left range start A, now it's 2. Okay, now it's 2, so that's when it goes over the range A end. Okay. In concrete examples, yeah, I know by doing experiments, but I was yeah, I mean, after a while I want to be able to think in the general standpoint. Yeah, let me think of it in general standpoint. I mean, yeah, I should do it after this recording. I don't want to make it long, so yeah, that is the second approach. Yeah, it took a while to explain it. So let me implement both of them if I have time. So the first one and second one. Okay, so let me open up a file, step1.py. I actually have something. Yeah, I was trying to solve it. Turns out I couldn't. Okay, so what we just said about the first approach, yeah, create a partition. Huh? Yeah, create a partition. It should be somewhere in the array. So okay, if so number of array is length of nums1 plus length of nums2, number of array, and if number of array divided by 2, we get no remainder, that means it's even. If even, so even value, so let's say 10 divided by, so to get the median, divide by 2, we get 5, and 5 is the sixth place. So return get value in array divided by 2 minus 1 plus get value in array divided by 2, and we want to get the half of the values combined together. And if it's odd, okay, let's say it was 11 divided by 2, ignoring decimal places, 5 is sixth value. 5 is sixth value. Sixth value is here. Okay, so we want to return this simply. Okay, and then now it's time to define get value, k being the target. It's like a target index that we want to extract from the virtual sorted array, and we have to think of am range start a or 1, because the parameter says nums1 and nums2. So this is int range and 1, range start 2. This is also int range and 2. And now I need to set default value 0, length of nums1 minus 1. This is 0 as well. Length of nums2 minus 1. Oh, I forgot to put this one, and get value. This is int. And then if range no we want to range start range end. Hold on a sec. We don't need this actually. We want a partition one int. This is what we want to get. And then this signature is not right. Okay, we have two partitions. We want to get the partition value right before the partition and right after the partition. So okay, this is a bit wrong. Let me complete the code first. Let's say let's just return some random values for now, okay? And okay, partition 1, okay, it starts from the middle. Okay, and then middle is length nums1 divided by 2 is the middle. And I want to use name mid inside the block, so let me oh, we don't need it. Yeah, we might not need it actually. We want pointer left that is 0. We want pointer right that is length of n. And then define mid pointer right minus pointer left divided by 2. Length nums1. And then what do I do? So in the basing on the first array, put the middle, and this is a candidate partition, right? And then see if that partition meets the criteria that it should meet. Meaning if we want to get before 1, after 1, before 2, after 2 from partitions. And if max value of before 1 and before 2 is smaller than or equal to the minimum of after 1 and after 2, that's great. That's let's say return, I guess. Yeah. And then else if before 1 is actually larger than after 2, then we need to see the candidate from the left hand. So prune right hand of the first array. L if before 2 is actually larger than after 1, to do prune before 2 is larger. Then we want to decrease the number of the, okay, so left hand of the first array. Raise value error. Expect an indented block after LF. Okay. Before 2, after 2, get values. You don't actually need k, so let's prune it. Is it a blank line? Okay. Undefined name get point. Okay, of course. And then return minimum max of before 1 before 2 plus minimum of after 1 after 2 divided by 2. And then another one if it's odd, okay, partition. Okay, then let's say 9, we want to get the fifth, 1 2 3 yeah, fifth index, and this is right before the partition, first partition, I mean the partition. Okay, so max before 1 or before 2. And then let's say get partitions and it returns tuple of int int int. Or it's kind of okay. Before 1 is safe get. Is infinite. Is infinity integer? What does the program use? Okay, float inf or float. Okay, and we want to get array list of int. If an array k is something that we want to get is an array, then we want to return float infinity. Does that even work? UV run python float infinity. Okay. What about inf? Okay, inf does not work. Infinity. Okay. And if k is lesser than 0, then return float minus infinity. Let me check. Float minus infinity. Okay. Return k. And okay, we get safe get. Before 1 is mid minus 1 of nums1. After 1 is save get mid minus nums1. Before 2 equals save get. Okay, then we need to get the second partition in the second array. Let's say the second partition is partition 2 is target minus mid, And what is target? We need to define that. The target is index of partition 1, index of partition 2. That represents if the partition is on 3, 3 means we have 0, 1, 2. So 3 items before the partition. Three items, the target. Then the target is index, and it starts from 1, so it should be target plus 1 minus mid. Which is slightly different from the solution, but let me try this one because I think this is more accurate. That means the number of items from partition right before partition will sum up to the number to the place of the median. That means the partition right before, okay, yeah, partition, yeah, if it's odd number, we want to get fifth place. And partition should be here, so okay, good. And if it's even number, we want to get fifth and sixth value. The partition would be number of items. Okay, yeah, partition 2 minus 1 nums 2 after 2 safe get partition 2 nums 2. And prune right hand of the first array get values. Okay. Target. Okay, target is and when we see this, it's already defined around here, right? No? Oh no. N array divided by 2. Okay, that is target. Missing. Hold up. Target. Okay. Target is index. Yeah. Yeah. Now we need to right hand, so pointer right is the same, but now we want to change pointer right. Pointer right needs to be updated, which is in this case right hand add, oh sorry, so mid -1. And now back to here, get values. Now it's mid +1 nums 1 blah. no. Length nums1. Okay, let me try to test it. If name equals to main, then solution test cases. Nums1 is this one. Nums2 is 2. This should return 2. Missing was after comma. Missing white space after comma. Ah, okay, got it. Yank, paste. 1, 2, 3, 4. 1, 2, 3, 2.5. And let me open up a code editor to run it. Get values. 42. Raise value error. Is that so? Really? Hold up. Okay, raises value error. So let me check. In the first iteration, before 1 is 1. After 1 and what what's mid? Mid is 2. Okay. Mm. Ah, okay. Hmm. So if before 1 and before 2 is 3 and minus if respectively, we get 1 3 1 3. And let's get after 1. Let's check if this condition is met. Yeah, the correct partition would be here, right after 2. And now the partition is here. We want to move it to the left. Right, so right now before after 2, after 2 is 2, right? Yeah, before 2 is inf, yeah. So it goes to here, get values. So basically right now partition is here, we want to search from here. In order to do that, set the right window Right now mid is 2, right? Minus 1. Is before 1. What do we want to do? Before 1 is greater than after 2, then that means we are getting too much from the first array. So we want to prune the right side. Okay. Right now mid is 2. So having 1 means we have partitioning here. Mid is 1. Okay. And okay. So before 1 should be 1. Okay. After 1 should be 3. Okay. Before 2 no, partition 2, because now the partition is here and we want the other partition to be here, so 1. Okay. Okay, so before 2 should be 2, right? Okay, after 2 should be if. And then right now should be good, right? Because okay, partition being here, partition being here, maximum. Yeah. What about now? Okay, it's returning. So by okay, return. Yeah, because it was the second nest. Even if it returns before 1, after blah 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 blah, it goes back to the parent stack. Okay, so return. Okay, now it's working. I'm so hungry. I'm not sure if to go to McDonald's. Let me grab some cookies. assertion error. Here we go again. Oh my god. Why doesn't my code always run successfully? It's 3.5. Oh my god. Why is that? Why is that? Let me set a breakpoint here. Before 1, before 2, 3, 2, 1, 2. No, before 1 should be 1, but it's returning 3. After 1 is inf. After 2 is 4. After 1. Oh yeah, this is wrong. This is completely wrong. In the first loop, before 1 is 3, before 2 is 2. We're getting too much. Because if before 1 is 3, that means we have partition here. After 3. After 3, we have the partition. Then that means we want permission before 2, meaning meaning 0. Yeah, meaning 0. We want to get 0, but we're not getting it. Probably we're getting 1. But mid is number of elements on the left hand. Let me put a formulation. Partition 2 number of elements on the right hand. This means number of elements yeah. and that number of elements on the right hand. 1 2 3 4, and now this is the partition. Nine divided by 2 is 4. Okay, now let's think about even numbers. Partition should be here. Ten divided by 2, 5, 5. Is index of where the partition should be. Now let's go back to 9 items. 4 is here. This is index, and that's where the partition should be. Okay, so +1 is not necessary. Hmm. Now we have another problem. Um, Okay, 10 10 divided by 5. Sorry, 1, 2, 3, 4 go 5 is here. If it's 9, it's 4 1 0 1 2 3 4 here. Or if partition is here, if partition is here, then if after mean after okay, let me submit this one. How many? Okay, 2 hours. Impressive. Hmm. Oops. Excuse me. Mm. Okay, 9 minutes. Okay, 3 hours. That's enough. I don't have time for alternative. I will create another video. So bye bye.